Since everybody could see this one, this is the one we're going to work with, right? All right. Now, generally, of course, we know where the kidneys are in the body. It's considered to be a retroperitoneal organ, right? This little structure that sits on top of the kidneys is considered the adrenal gland. And we learned that the adrenal gland is separated into the cortex and also the medulla, right? Now, the kidney itself is also separated into the cortex and the medulla, okay? So this region here to here, all the way around, right, is considered to be the cortex, okay? Anything below this point, of course, is considered to be the medulla. Again, cortex and medulla. Now, one structure that it's on your lab list, of course, they ask for the helium. And the helium is that site at which the vessels they enter into the organ. So this region here, of course, will be considered the helium. Okay? Nothing so tricky about that. Okay? So let's continue learning some parts. This structure that you see here, here, these are called the renal pyramids. Okay, so all these are the renal pyramids. So what do you think this is?
Renal pyramid.
Very good. It's a renal pyramid, okay? So this is a renal pyramid that they haven't made a cross section of. If you make a cross section, it's going to look exactly like this. So all of these here are renal pyramids. So a natural question to ask, where are the renal pyramids? In the medulla, okay? Now, inferior to the renal pyramids, we have the renal papilla. Okay, so this lightly colored stained areas here is considered to be the renal papilla. Alright, moving forward, right, the first part that we come to after the renal papilla, this here is the minor calyx. Okay, so minor calyx. Then a little further in, about here, we'll say that this point is the major calyx. Alright, and then going further now, this whole thing here, I'll draw a circle for you. This whole thing here is considered to be the renal pelvis. Extending from the renal pelvis is the ureter. And the ureter extends all the way down into the urinary bladder. Other important structures for you, for example, is the renal column. This space you see here between the pyramids, they're called the renal column. So here's a renal column, renal column, renal column. Okay? A little bit about the blood supply. The main supply is via the renal artery and the renal vein. Of course, the renal artery is a branch of the descending aorta, and of course we have the renal vein, which is a branch of the vena cava, right? Okay. Now, if we come in, right, and there are a number of branches, the first branch, it branches out like this. We call it the segmental artery. So just like how you have a segmental artery, you have a segmental vein as well. Okay? Now, these now proceed to form, right, the interlobular artery. So this right here is the interlobular artery. This interlobular artery now proceeds and it goes around the pyramids. If it goes around the pyramids, it's called the arcuate artery. From the arcuate artery, we have these blood vessels that extend through the cortex, and these are called the cortical radiate artery. So again, all of these here are the cortical radiate artery. Okay, so let's go over that again. We have the renal artery. Okay, we have the segmental artery, we have the interlobular artery, and we have the arcuate arteries. Okay, and then we have extending from the arcuate arteries, we have the cortical radiate arteries. Now, one step further, we learned yesterday in class that there are two types of nephrons. There's the cortical nephrons and the juxtamedullary nephrons. Now these all the way up here, we consider these to be the cortical nephrons. However, the ones that are lower here, close to this line here, the juxtamedullary zone, right, we say we have the juxtamedullary nephrons, okay? Now, you may notice that all you see is a circle that is colored in yellow. This whole circle that is colored in yellow is considered to be the renal corpuscle, right? Well, what really is a renal corpuscle? The renal corpuscle, if we magnify it, looks somewhat like this. It's a combination of both the Bowman's capsule and the glomerulus. So collectively, we call the entire thing renal corpuscle. But if we can actually point to each one, this here will be the Bowman's capsule, and this, of course, will be the glomerulus. Now, some of these, on some of the models, you may be able to see the glomerulus and so forth, okay? But for the most part, collectively, because that's all we can see, we can't see on the inside, these will be the renal corpuscles. Now, the first part of the renal corpuscle, right? For example, if here's a renal corpuscle, and this here is the tubule, right? Now, the first part of this tubule is called the proximal convoluted tubule, right? Now, it's a little better on this one, okay? This right here, of course, is the renal corpuscle collectively. The white around it is called what? The Bowman's capsule. The red is the glomerulus, but collectively it's the renal corpuscle. Another name for the Bowman's capsule is what? Glomerular capsule. Okay? Alright. Now the tubin that extends off of the Bowman's capsule, right? This tubin here is called the PCT, or the proximal convoluted tubule. Right? Now extending from the proximal convoluted tubule, we have this loop. And we really just call the loop of Henle. Okay, extending further, we have the distal convoluted tubule. Well, the distal convoluted tubule is an extension of the ascending limb of the loop of Henle. So if this is the ascending loop of Henle, an extension of that is nothing but the DCT, distal convoluted tubule, that makes its way all the way to the collecting duct. Okay, so let's go over this now. Now, since this is very close, right, to this line here, I would like to call this nephron a juxtamedullary nephron. However, these that are further up, I would like to call them the cortical nephrons. So let's look at other structures that we find within the nephron themselves. Now, do you see this branch, right, that goes in, right, and form the glomerulus? So this has to be what?
Afferent.
Right, the afferent arterial, and then it comes out, right, and it forms the efferent, and all of this right now is the peritubular capillary. But since this nephron is so low down, once the efferent forms these tubules that surrounds the nephron itself, it's either called the peritubular capillaries or the vasa recta. If we were talking about the juxtamedullary nephron, we'll call this the vasa recta, but if not, we'll simply call it the peritubular capillaries. Okay? So let's look at it one more time. This right here is what? Where's pointing to?
The middle glomerulus.
The glomerulus. If I pointed to here, what would you call it?
Bowman's capsule.
That's right, because I can't see what's in it. That's the whole thing. But if I point to the red is glomerulus. If I point to this is renal corpuscle. Okay. Now this one here, would you call this a cortical nephron or juxtamedullary nephron?
Cortical.
Right, and this one would be a better example of a juxtamedullary nephron. Okay. Okay. So let's look how does this work. Well, what happens is that the blood is continuously filtered by the glomerulus. and only the materials or the solids that are small enough to pass, it passes through the Bowman's capsule, and then of course it makes its way all the way through the proximal convoluted tubule into the loop of Henle, distal convoluted tubule, and eventually it makes its way into the collecting duct. So what ends up here at the end of it, right, is really urine, right? Now, this urine is void of anything that the body really needs, right? So what do I mean? Well, all throughout the length of the nephron, we have reabsorption taking place. So things like at least 67% of the sodium chloride is absorbed at this level. We also have secretion occurring, right? And secretion is normally from the red blood cells to the kidney tubule itself. And that allows certain substances to be excreted. Now, what do I mean? Well, not all substances are freely filterable. You have read that in your text, right? Some of the substances, they have to be secreted. When we say secreted, we simply mean from the peritubular capillaries into the nephron tubule itself, and that will make its way eventually to the collecting duct. Okay, so now we are the collecting duct now. We have this region right here, the renal papilla passes through, and eventually it makes its way to the minor calyx. From the minor calyx, it makes its way to the major calyx. Then it's going to go to the renal pelvis, and then it's going to go to the and then it goes to the urinary bladder. Okay? Now, other structures that they may ask you for is these sinuses. Okay, and these are the renal sinuses. This right here is a fat lobule. Okay, a fat lobule. One thing I didn't mention is this this capsule here, and this capsule is very important because it's supposed to prevent the inside of the kidney becoming infected. Okay, so it's a fibrous capsule that prevents that. You'll see it here as well. Okay, now this model here, it shows you a number of things, okay? It not only shows you the renal corpuscle as it exists with both the Bowman's capsule and the glomerulus, but it also shows you the juxtaglomerular apparatus, right? Or the juxtaglomerular complex, right? So, what is the juxtaglomerular apparatus made up of? It's made up of the afferent arteriole. Well, could it be the efferent arteriole? Yes. But most of the times we're going to see that it is the afferent arteriole that is involved in the apparatus itself. Now we can certainly tell the difference between the afferent arteriole and the efferent arteriole. The afferent arteriole, of course, we see is much larger than the efferent arteriole. So we look for these special cells within the afferent arteriole. These cells are called the JG cells, meaning juxtaglomerular apparatus granular cells, or just simply just call it granular cells, right? This right here, of course, is the distal convoluted tubule, or an extension of the ascending limb. Okay, so again, nothing but the DCT. Now these cells here are very important because it is called what? Macular densa. Okay. Now we also have a network of cells between the DCT and the afferent arteriole. You don't see it there, but it is present. And these cells are called the glomerular mesangial cells. And these mesangial cells provide a connection between the macular densa cells of the DCT and the granular cells of the afferent arteriole. Now, other structures that are very important are these cells here. These cells are called the parietal cells. Okay, they are parietal cells. Okay, Now, the parietal cells is just like simple squamous epithelium. Now, there's a space between the glomerulus and the capsule. That space is called what? The capsular space or the Bowman's capsular space. Okay? Continue on. This structure we have here is referred to as the glomerulus. But we see that there are different regions of the glomerulus that are slightly indentated. Right? These are obviously called what? The podocytes. Right? The podocytes are also referred to as the visceral epithelium. Okay, so visceral epithelium. Okay, continuing on, right? When we extend beyond the Bowman's capsule, we have this special type of tissue here that we call what? The proximal convoluted tubule. Okay, is that good? All right.
That space right here, is it right here?
Yes, ma'am.
Okay.
That space. See that space there?
Yeah, the glow.
So the cells here are parietal cells. What about those
Yeah.
cells? They look like cuboidal.
Yeah, the cuboidal cells.
From
Right?
squamous to cuboid.
Right, and you can see that these parietal cells are really simple squamous epithelium.
And then
Okay,
they form into cuboidal.
and
they
then
go into
when we form the PCT, we end up with the cuboidal. Remember, we said in class that these cuboidal cells are unique in that they'll be highly what? Microvilli, right? They'll
yeah.
have lots of microvilli, and we look at them, they'll be opaque. Okay. Any other questions so far? No? Okay, let's do this one
Sorry,
right
I
there.
see the minor calyx I see clearly. So what is the major one?
Okay, it's just a region.
Okay.
If here is a minor, so about here, about 1.5 centimeters, here is a major.
So two minors coming together form a major.
Right, so here be minor, here be minor, here be major, here be major. And then it continues, then you form the renal pelvis. Okay. Structures you know already, right? Obviously the kidneys and so forth. This right here is the ureters, okay? And here we have the ureters entering on the inside. It forms these two holes, or it's supposed to form these two holes on the inside, and you usually call them the urethral openings, okay? But this right here is a triangle, and this triangle is referred to as the trigone, okay? We also have the muscle within the bladder itself. Muscle is important because the muscle is the detrusor muscle, alright? Now again, these are the ureters that enter. The next one we have is the urethra. Okay? Anybody has this is the bladder. This is what the bladder looks like. Of course, we have this nice triangle. We call it triangle, the urethral opening and so forth. And then extending outward, we have this nice little prostate. And about this region right here, on the inside, on both sides, we have the internal finster, I'll put an S, right? This we know is the prostate, right? And anywhere around here, of course, you'll have another finster, and again, this is the urethral opening that, of course, opens to the outside. Now, this right here is given a special name. We know it's a urethra, but we'll call it the prostatic urethra, right? On the inside, right here, sorry, on the outside, once it passes this external finster, right, we'll say that that is called the membranous urethra. Okay? Alright.
Where's the orifice?
The orifices we have here, here.
Oh, okay.
The orifice is just opening, but it's called urethral openings. Okay? Now you also see a bunch of these, right? And then see it like a wall you see here. Now this wall here, of course, it's made up of muscle, right? So what type of muscle is that? Detrusor muscle, right? Okay, so detrusor muscle. What are these contours called here? Believe it or not, rugae again, okay? Now remember I said this is the internal fencer and this is the external fencer. What is unique about both fences, they're made of two completely different type of muscle, right? The internal fencer is made up of smooth muscle, right? Whereas the external fencer is made up of skeletal muscle. Right. There's two other structures. Let's say there should be one here that kind of anchors the urinary bladder in the pelvic floor, and this is called the medial umbilical ligament. Right, and there's two on either side here. Right, this will be the lateral umbilical ligament. Okay, don't worry about these two ligaments for now. I just mentioned these because most people want to know, well, does this stay in? Stay in position. Okay, right. But these are all things that you'll be asked. For example, you'll be asked the trigone, and this is this little triangle that is found there. This, of course, we know is the prostate, right?
Is that what that is?
Yeah, this here is the prostate.
Okay.
Yeah.
I was just going to see if you can show us those things on the model here, because I think some of them are here.
Yeah, this is more reproductive. We'll do this again. But but if you have a question here, this is just the
bladder.
The bladder showing you the rugae. This here is the internal, and this here is the prostate, and this is the external, and this is the urethra. Okay. Remember
the umbilical thing you're talking about?
from the bladder.
Holding up the bladder.
Yeah, I think they'll like to say that days where it should be lateral umbilical ligament. So it's really a ligament.
So you can't see the ureter here.
Second.
Ureter.
No, this right here?
What is the? You can't see it, the ureters here.
No, I don't see any ureters there. Okay, and of course this is male, this is a female. Okay.
So the female doesn't have the external, has the external sphincter. Where is his own internal sphincter?
Right.
Is that it?
As you go further, right, the internal should be more on the inside, and the external is supposed to be more on the outside. Yeah. Okay, but that's more reproductive, and we'll talk about that. But we know the prostate, right? And what happens, like in certain, like in the prostate, what happens if it's enlarged? What happens? It squeezes the urethra, right? So GF4, right? GF4 urine will no longer flow steady. So in a normal person where there's no constriction of the urethra, the urine tends to arch, right? However, in males with benign prostatic hypertrophy, because of the enlargement of the prostate, it constricts the urethra, right? So there's no longer that arch flow. Instead, it's wetting the male's shoes, okay? All right? Typically, of course, you could know what is happening to the prostate based on a digital rectal exam, or you could do a blood test, the prostate stimulating antigen. Of course, just because the antigen is high, it doesn't mean cancer, although most of the cases it does, because in BPH, which is benign prostatic hypertrophy, it's not cancer, there's the prostate just simply enlarges. Of course, you could easily treat that. In digital rectal exams, you could actually, these two spaces right here, if you palpate that, that is what a prostate feels like. Without putting your finger in somebody's rectum. Okay? That is what it feels like, okay? In case you guys didn't know. Alright? But most of the time, you're supposed to go up and you'll feel an elevation in the prostate. It's supposed to be nice and smooth like this. Right? However, if it feels bulby or it feels nodular, of course, you'll want to get a biopsy there. Alright? So that's a little bit about the prostate. We know where everything is now. Okay? There shouldn't be a problem. Okay? So all we have to cover really is the kidneys as a whole, the ureters, urethra, and the urinary bladder. Alright, so have a look at that. We have a